Hello boys and girls, welcome to Facility Maths online class. In this video, I'm going to show you the solution step for test yourself in the topic of complex numbers. So this is the given questions. You have three main things that you have to do for these complex numbers. First of all, we are going to express the z in the Cartesian form. Okay, secondly, we are going to find the modulus and arguments of the complex number z. And finally, we are going to express the z in the polar form. So first of all, we have to simplify the complex number z first. So how are we going to do this? Well, we may use the calculators to evaluate the value of cosine and sine. So before you do anything, you must make sure that you change the calculator into the radian modes by using the function press the button shift and E, and you choose the 4 as a radian. So by using the calculators, so we get the value of cosine pi over 4 as 2 over 2, sine pi over 4 as 2 over 2, cosine pi over 6 as 3 over 2, and finally sine pi over 6 as 1 over 2. So we substitute the corresponding value and we simplify it to get the value of 2 multiplied with 1 plus I divided by 3 minus I. After that, we multiply with the conjugate of 3 minus I, so it's 3 plus I divided by 3 plus I. And we expand. For the numerators, we get the value above, and for the denominators, we may expand by using the concept of a square plus b square. That is, we will have the 3 square plus 1 square to get the value of 4. And finally, we collect the real part and the imaginary part as this to get the Cartesian form of complex numbers z. Part B. To evaluate the modulus, we use the formula of square root of a square plus b square, and we evaluate and simplify to get the value of 2. Okay, so to evaluate the argument, first of all, we locate the complex number. We know that the z is the first quadrant, so the formula of the argument will be the arctangent b over a. So by substituting the b as 1 plus 3 over 2 and the a as 3 minus 1 over 2, use the calculator to evaluate. So we will get the value of the argument as 5 over 12. Part C, to evaluate or transform the complex number into the polar form. So we use the formula of the r multiplied with cos theta plus I sin theta. So remember, the r is the value of modulus and the theta is the value of our argument. So you just substitute the corresponding value to get the polar form of z.